Cool. All right, so we'll just kick straight off. Thanks everyone for joining. Next on the 102 track, we've got Drew and Andrew from IBM, both in the modernization squad within Kix, looking at Ansible today. So it's a Ansible talk for zOS. These guys are pretty much the experts when it comes to Ansible within zOS and Kix. They know far more than I have any knowledge of. So I'm not going to try to sum up what they're going to talk about. I'm going to hand it straight over to them. As always, please do the session feedback at the end. I'll remind you at the end. I will pop the link in the chat. Feedback is great. We can work out what we need to do better for the next sessions. And without further ado, I'll hand it over. Thank you.
Awesome. Thanks, Lewis. Good afternoon, good morning, everybody. So as Lewis said, my name's Andrew. I'm joined by Drew, and this is our introduction to Ansible on zOS. I'm going to be starting off today with a demo, just a bit of a teaser of what we're going to be talking about, and then we're going to talk about Ansible, a bit of an introduction, talk about the ecosystem, and then a little bit more about Ansible on Z, and Drew is going to do lots of demos for us. So jumping straight into the demo. So I'm hoping you can see my VS Code window here. So this is an Ansible playbook. So a playbook is a YAML document that describes a piece of your automation. And we're going to work our way down, explain what's going on and run it, and hopefully see some green outputs. So starting off at the top, we are specifying our hosts here. So hosts is where we want to run our automation, where we're going to target this playbook. And we've given the hosts zOS host. So in Ansible, that means we have to look in our inventory file. And an inventory file specifies all of our target systems that we want to run automation against, and they're named. So zOS host here specifies how and where we have to connect to this system. So our Ansible host, our user, so who we're going to connect as well as some other information about where Python is installed, and some other SSH arguments there. So go back to our playbook. Now we know where we're going to run our automation. We need to provide some other bits of information. So our environment, we can pass in some environment variables. Now these are in a separate file in our vars.yaml, and this is some information for ZOAU, which we're going to talk about a little bit later, which is Z Open Automation Utilities. And these are some environment variables used there. We can then hard code some other other variables that aren't in a file, so we can write them directly in the playbook here, which are some dataset names that we're going to use throughout the playbook. So I've set a source dataset and a load library because we're going to do some COBOL compilation in a second. So there we're setting some variables there, and using those three files together, that's really big, we can run our playbook. So I'm going to do Ansible playbook, point to our inventory file, so specify where our system is. We are going to tell Ansible where our variable file is, and then we're going to give it the name of the playbook. So I'm going to kick this off running, and then we will put it to one side and watch it tick through as we explain what's going on. So we then get to the tasks section, and this is a list of tasks that we're going to perform in this playbook. So we're going to start off by creating a couple of data sets here. So we're creating a source data set and our load library data set using the zOS dataset module, which we're going to jump into later. And we specify some things like the dataset name from here at the top, and then the dataset type and some space details, record format, record length, all the information you'd need to create a dataset. We then copy some local COBOL source to the dataset. So that local COBOL source is actually on my laptop, and I'll open the file up here. It's a super complicated COBOL program. Don't have time to explain it all. Basically, we're going to print hello. That's our COBOL program, but it's on my laptop. And what Ansible's going to do is it's going to copy, using the zOS copy module, copy that COBOL to our source dataset. we're doing some encoding, and I've set false as true, which will overwrite the dataset if it already exists, which it does because I ran this earlier to make sure it works. But we're copying that COBOL to our remote system. We then run a compile job. I'm actually keeping up with the console here, which is quite cool. So we run the compile job. Oh no, it's failed. Okay, we'll look at that in just a second. But we run our compile job. So this is a templated bit of JCL. By templated, I mean using Ginger templating. So this is a way of substituting values from our playbook into the JCL. So our source data set and our member name can be swapped in at runtime. And we run that job, which I believe is the task that failed. So we'll come back to that in a second. Yeah. We can then get the output from that job and print it out to the console. And then we submit another bit of JCL using the zOS job submit to run that program that we compiled. When we've run the program, we can get the output and also print that to console. Print that to the console. So without spending absolutely hours on why this has failed, I will do one lookup to see. But failing that, we will move on. It have ended. Classic. Okay. Maybe we'll come back to this at the end, Drew. Absolute classic. So now that I've shown you a bit about Ansible and how it works, member name wrong. Oh, somebody spotted it. That's odd. Doesn't matter. We'll come back to that. So let's go into a little bit about what Ansible is now that we've seen some of it in action. So Ansible is an industry standard automation tool. So it's used for automating repeated tasks that you normally do manually over and over again. And you can either run Ansible manually like I just did, or you can set it to run on a schedule, things like that. It promotes configuration as code. So it allows your automation configuration to be maintained in a source control system like Git, which means multiple people can contribute at the same time and make changes to it. But those changes can also be reverted if necessary in a safe way. It's also a single source of truth then for your automation. You don't have two versions of the same bit of automation on two separate people's machines, differing in state. That's their tagline on screen there, turning tough tasks into repeatable playbooks. And Ansible is a great way to normalize your tooling across all platforms. So Ansible is not just a zOS tool. It's very much cross-platform. I'm going to talk about the requirements a little bit later, but essentially, if a device or machine has an SSH connection, it can be automated with Ansible. So obviously, we were automating against the mainframe there, but that could be databases, it could be virtual machines. Even certain network switches have SSH enabled, so you can automate those if necessary. So a couple of key terms for Ansible. So a managed node, that is the remote system that you're targeting. So it could be one system, it could be multiple. There's the systems that your playbooks are targeting. In that demo is that zOS host, which was our test system. And then the control node is where the Ansible is being controlled from. So it's where you're running the playbooks. The demo, it was my laptop. But again, this could be triggered elsewhere. It could be a virtual machine. It could be a container running on a schedule, things like that. It's just where the playbooks are running. Those playbooks, as I said, are the YAML configuration that define the steps that you want to perform and where to perform it. And it's made up of tasks, which are individual steps. Each of those tasks has a module, which is the bit of functionality, the bit of code that's going to execute, and then the parameters to tailor it to what you want it to do. And finally, collections, which are extensions to Ansible's functionality, which we're going to talk a little bit more about later. I've got a quick diagram here about the structure. So you've got one control node versus multiple managed nodes. You don't have to, could be one, could be multiple managed nodes, and it is powered by SSH by default. It doesn't have to be powered by SSH, however, you can do different protocols, but everything we're going to be showing today is an SSH connection. So inventories, I showed you an inventory in the demo. It's how you tell Ansible where your managed nodes are and how you're going to connect to them. It's a flexible way of describing your environment in a YAML format, and you do specify details like your host, your port, your credentials, SSH keys, and you name them. And naming is really important because you can run a playbook against one managed node using its name. You can group nodes together into groups and name that. So you can run the same piece of automation against multiple systems in a group. You can define variables directly in your inventory as well. So scoped to either just one managed node, a group, all of your nodes in your inventory as well. And playbook, something we've already talked about plenty. So these are the list of tasks that you want to perform. This is an example of a playbook. Granted, it's a very simple playbook. There is only one task, but we provide a name and which host we want to target. You can use keywords like all to target all nodes in your inventory rather than providing each one. And then our task is down here, which is a task to to get the information about the dataset using the zOS MVS raw module. So this module runs a program. So we have to specify a program name, which is idcams. And then we're passing in the listcat command right at the bottom there as one of the parameters. And we're specifying that return type would be text. So you can imagine you'd use this kind of tasks to inquire about a data set, firstly, to see if it exists, and secondly, to get information from that listcat command, like the dataset type and its sizes, things like that. So the Ansible CLIs. So Ansible is a Python package. So you install it with pip. Pip is Python's dependency manager. So you can install Ansible that way, and that comes with lots of CLI tools then available to you. So Ansible Galaxy is a common tool to find and install collections. So these extensions to Ansible. That's what that tool is used for. Ansible Inventory is another useful one to display how Ansible sees your inventory file. So you can see if Ansible is picking up your managed nodes information correctly. And Ansible Playbook, which is used to run your playbooks. And on the bottom there is an example of running a playbook, passing in an inventory and some runtime environment variables as well. So collections, I've already touched on these a bit already, but these are the extensions to Ansible's core functionality. So Ansible comes built in with lots of built-in functionality, but collections allow you to expand that and create custom collections if need be. It's a distributed format, so it can contain playbooks, modules, plugins, roles, and it's Ansible's way of packaging up that functionality to be shared. There are a variety of zOS-based collections that we're going to look at in a second, which is how we distribute that functionality. So how do we store and distribute those collections? With Ansible Automation Hub and Ansible Galaxy. So Ansible Galaxy is a public repository of open source roles, collections, playbooks, etc., which anyone can upload to. Java has Maven Central, Python has pip, Node has Node Package Manager, Ansible has Ansible Galaxy. Automation Hub is the enterprise marketplace for content. for Ansible automation platform users. So this includes public certified content by Ansible, which is content that is maintained and supported by Red Hat and IBM. But you can also have Ansible Automation Hub as a private on-premise repository as well to share content just amongst your organization. Ansible Automation Platform is essentially a wrapper to everything I've just said. So the CLI is one way of running your automation. Ansible Automation Platform offers a slightly more, well, a nicer way of running it, basically. It's a graphical user interface. It's buttons and drop-down menus to run your automation. It's got an interface for inventory management, playbook configuration, environment variable setup, scheduling as well. It can pull your automation straight from source control. So if you've got your playbooks in Git or another source control system, it can pull those directly and manage them for you. It adds things like role-based access, so you can control who runs which playbooks. And it's just a cleaner, non-terminal based approach for running your playbooks. So now that we know lots about Ansible and how it works, what do we need in order to run that on zOS? So there are a few requirements. So I've talked about SSH already. Again, although it's not a requirement, you can run other protocols. The zOS collections are, we run SSH in our demos and samples. Ansible is a Python package, so you need Python installed on your managed node. The reasoning being is Ansible packages up little snippets of Python code, sends them over to your managed node and executes them, and then sends that response back to your control node to be unpacked. So that is why you need Python installed. And finally, you need IBM Z Open Automation Utilities, or ZOAU, which are a command line, USS-based command line set of tools for interacting with MVS resources. I'm not going to go through everything right now of what they can do, but things like manipulating data sets, as in creating them, writing to them, deleting them, etc., job outputs, running programs, submitting JCL, etc. Those utilities also come with a Python API, which are used by Ansible and the Z Ansible collections to run in the background. So that is why that is a requirement. Drew, are you taking over?
Yep, go on. I'll start sharing. See if we can find it. When I find the button, that is. All right, here we go. Slideshow for current slide. So yeah, at this point, now Andrew's given you a great intro into what Ansible actually is. It's probably worth talking about these certified collections. So Andrew's already shown you some tasks here from the zOS core collection, but there's actually a number of different certified collections here. So we have one for zOS core, which generally gives you actions to manage data sets, to manage jobs, to manage to run TSO commands. So basically, the types of things that you want to be doing more general purpose across any subsystem on zOS and general zOS automation tasks. Good one would be doing something like checking the status of a job that you've just submitted, something like that, or creating new data sets and making sure that that data set has the right content, and then also removing that data set if possible. There are a number of other collections. So there's a IMS collection that helps, but does all sorts of things such as management of IMS instances, but also provisioning of those instances. There's some system automation ones, one for the hard HMC one. I've forgotten what HMC stands for. I think it's Hardware Management Console, but I'm not going to go into that. And there's another one for zOSMF, which allows you to take your current sets of automation. So if your current automation in your organization is based on zOSMF workflows or submitting JCL or just basic jobs or recs, you can take existing Ansible collections and do in-place modernization of that automation and run all your existing automation with Ansible, but also look at maybe running some newer custom automation purely with Ansible tasks. Right. Okay. So yeah, there's also this brilliant samples repository. This is all open source. It's on public GitHub. This little screenshot of it. This is the actual link with. This will be in the slides at the end, so you can download the slides and find this link if you need to. But yeah, there's lots of very varied things that you can do with Ansible. And this shows a huge range of things you might be looking at, such as infrastructure provisioning, or simply just lifecycling jobs and creating data sets. So this also covers all the subsystems, so IMS and Kix samples as well, but also just a lot of really good generic zOS-based samples to try and get you to have a think about how you could take existing automation or just create new automation to do stuff. A brilliant example is showing you how to do certificate rotation on zOS, which you can fully do with Ansible. That's one of the most popular samples that we have and is used quite commonly in demonstrations. So yeah, I've spoken a little bit about the zOS core collection. So this is for more general purpose zOS functionality and zOS tasks. There's some extra ones as well, such as being able to submit operator commands. So if you think about maybe sending the command from SDSF, you can do that directly in Ansible using an operator command. You can also do things like mount zOS file systems, APF authorized libraries, or execute TSO commands. It's very varied and very, gives you a lot of power to do a lot of things very easily from a low code point of view, without having to know much zOS fundamentals, but getting started very quickly. So I think I'm going to do a demo quickly. If I can get out of, this, there we go. Right, are we on the right one? Yeah, cool. Okay. So this is a simple playbook again that, just like Andrew showed previously, this is another playbook using another zOS core task, but this is a far more cut down version, just to show you this is one of the very simple things you can do with Ansible, and you can just run any TSO command you want. So let's just run that against my inventory again is just another zOS machine. It's an LPAR we have here in Hersley. I have the same ZOAU and Python arguments that Andrew was showing previously. My task this time is just simply to run a RACF commands using TSO. And I can do a list user on my user and see my RACF groups. It's as simple as that. So yeah, playbooks don't have to be overly complex and describe a full end-to-end scenario. You can use them just to do very simple, small actions. Let's go back to the PowerPoint. So yeah, I touched briefly on the Kix collection previously. I'm going to go into a little bit more detail here. I know the audience might not be a Kix audience, so you might not care too much. So apologies. But the Kix collection is what me and Andrew spend our day jobs working on at the moment. We currently have a fully released collection that we've had for about 2.5 years, I want to say. That gives you the ability to run Ansible automation against something called CMCI, which is the HTTP-based endpoint to manage instances of Kix. So manage resource definitions and that type of thing. Again, if you're not into Kix, apologies. We have been releasing this new beta capability as well recently that allows you to create specific types of Kix datasets, which are required for creating instances of Kix, so Kix regions. This is all being developed in the open again, like all these Ansible core collections. So everything's under Ansible-collections. And it's also available on Automation Hub and Galaxy. And just to give you a quick look at what some of the Kix stuff looks like. We have this provisioning playbook here. This is a slightly different looking one. We haven't previously covered this thing called the module defaults. Basically, if you have lots and lots of tasks that all have the same variables, you can use this nice little workaround thing called module defaults to apply essentially all of these under each individual module in each task in the exact same way as that. So that's all that's doing. It looks a little bit complicated, but it's just doing that. Apologies. So yeah, if I run this playbook quickly, it does take a second. It's one of the more interactive ones, so it has a vars prompt. So let's just enter an Apple ID quickly. So okay, 2Z, PZ1. I can quick port in. I'll let this go ahead, and then I'll try and explain what's going on in this playbook. So we have
Drew,
costs.
sorry, while it loads, you've got a question in chat if you want to take it quickly.
Oh yeah, go for it. Yeah.
The question is, can you list any other users and bypass a rackf? And that was in relation to your list user command.
Absolutely not. It's the same. It's same as doing a TSO command directly on Unix system services. So if my user has the ability to do that rackf command, then I can do it. If I don't, I can't. So there's no bypassing rackf here. It's the exact same thing as just doing a TSO CMD command directly on Unix system services. But yeah, good question. So yeah, we have these tasks here. They go through, create quite a few different types of data sets. I think we have 10 here in total. I'm not going to count them quickly. And then we have another task here at the bottom to actually start the Kix region. For those of you familiar with Kix as well, you might recognize we're doing this thing with updating the CSD with a CSD UP script. So we provide the ability to put any CSD UP commands directly into a script and apply that against a CSD. So yeah, just going to let this finish up quickly. Yep, getting there. LCD, I think that's the last one. Yeah, here we go. So yeah, you can see this start Kix task actually generates a piece of JCL and then does a job submit on this JCL, which is slightly different to how the other dataset tasks work and how slightly different to how you might expect some of the tasks to work. But this looks more like a traditional piece of zOS automation. Yep, now it's up. I'm going to switch over to 3070 to show you that I've just created all these datasets. Let's get another 3070 terminal going quickly. Should have one. Should have two of these. And do a quick log on. Apple ID. RK 2Z, BZ. Nice. There you go. Region for vision with Ansible. So as simple as that, really. Cool. Okay. Might as well show it quickly. We do have another one here called deprovision. I really shouldn't have cleared that. I'm going to need that job ID. Yep. We can also deprovision a region using an Apple ID and using the job ID, and we go through just delete the same data sets in the exact same way. I'll start this one here actually, and then we can carry on with some other demos. So IBM Z Open Automation Utilities. We have touched on this previously, saying that you need an install of this on zOS Unix. And the reason for that is pretty much all the fundamental stuff that's going on underneath the covers of Ansible is running ZOAU. It's running ZOAU via a Python API, but the thing that's creating the datasets, the thing that's listing the jobs, the things that's doing the submitting the TSO commands, that's all just ZOAU. So ZOAU is a way of interacting with MBS resources directly from zOS Unix, either through a series of shell commands and the shell API, or directly via a Python API that, that interacts with the fundamental stuff. So you have a command API and a Python API, and they're both touching the same thing. So it's the exact same installation path. It's all one product, so you don't have to get the Python bit and the command bit. It's all just one package. So yeah, it's super flexible, allows you to create Python or shell scripts directly on zOS Unix, but also running this stuff through Ansible for a low code point of view and through a managed point of view. So you can kind of think that if you're trying to do something like create data sets, doing that directly while having to be SSH into zOS Unix is probably not something that you want to be doing for an organization-wide automation point of view, but you might want to run that through AAP. So it gives you a bit of both worlds here. So yeah, why would you use zOAU? Well, it's pretty simple interface and it's very powerful. So it gives you more of a natural experience for people who are maybe more familiar with Linux or other Unix-based operating systems, and allows them to do pretty much all your MVS basic, your MVS common tasks directly through a familiar interface without having to write JCL and without having to write Rex. And it also has a full modern API using Python. So for newer developers who are leaving university, the chances of them knowing Python compared to them knowing something like JCL or Rex is probably pretty high. It's actually a first programming language that I learned when about 10 years ago when I was 15. So yeah, I'm just going to go through some examples here. So we've shown a couple of different Ansible tasks here. On your left is an Ansible task. On your right is a command that you can directly type into Unix system services, and it runs a zOAU command. So this one here, job query, does job query on the name. That's equivalent to doing the command called jls-l on a job name. So yeah, nice and simple. Slightly more complicated one. This is a Ansible task to do MVS raw on the IDCAMS program. So MVS raw allows you to actually call any MVS program. And then you can give it a series of DD statements, same way you would in JCL. That's roughly equivalent to doing the following, where you're echoing a string in this case directly to MVS CMD auth, which is the same as doing an authorized call of MVS CMD. It's the same underneath program. It just depends what program it has, if it has to execute an APF authorized program or not. In this case, IDCAMS is. So yeah, and then the one on the right just prints out the command back to the standard out interface. So then you could pipe it on to another process, and you could chain processes like that in a script, or you could just do that interactively in the shell. And then I think I've got a third example here. So submitting a piece of JCL directly from a dataset. So having, submitting JCL, PDSE, got a member here. Same as doing the JSON command. So yeah, let's actually show you some more zOAU in action here. So here, okay, I am currently logged on to a LPAR here in Hursley, running a bash terminal, and I've got some stuff on that bash terminal. So I'm not going to go into it too much, but I'm in zOS Unix at the moment. So let's do some commands. So we can do something called the DLS. I'm going to do it on my high level qualifier. I'm going to do it on GSE. Let's do demos. That should tell me I have no data sets on this. So DLS is to list data sets. Same way LS lists files, DLS lists data sets. So very kind of Unixy feeling, Linuxy feeling. So we have no data sets under there. Cool. Let's do a de-echo of a string. So let's do the classic programming example. Why not? Hello world, directly into a new data set. And I am really hoping I am going to get all this right. Otherwise, I might have to. Let's do it into demos. Samp. Why not? Cool. Let's do a DLS again. And we got a new data set. Cool. So let's use another command. So again, Linux feeling, Linux theming here. We'll do a decat on that data set. Right. Demos.samp. There we go. Let's chuck some more content into that. Hello world from GSE UK virtual 2024. And we can do a cat again. There we go. Well, I don't really want this data set hanging around, so let's do a DRM. So just like removing the file is RM, DRM is removing the data set. GSE demos. Lovely. And let's do a DLS. And I've cleaned up. No more data sets. So yeah, that's a nice little intro into using the shell. They all have really, really useful help pages as well. So this is JSub, which is submitting a piece of JCL. You get this lovely information about how to do debugging, how to specify all your options, some examples as well, nice little description, and obviously exit values as well, which is really important when you're trying to do this stuff within the shell scripts, and you're going to have multiple of these commands that pipe into each other. And you might want to, for example, exit your shell script at one point if you do an exit one at any one of these commands, and then that way you won't continue and do other actions when one of the previous ones failed. So yeah, super useful. I am in this directory briefly. I am going to show you this. You know what? Let's directly go in and have a look. So I open Vim. So this is a piece of Python. Apologies to those not familiar with Python. Yeah, it's not the clearest, maybe, what's going on here. I'll talk through it a little bit. The clue was in the name of the file being tso.py, but this is using zOA_util_py, which is the Python API for zOAU. In here, we're going to be doing we're going to execute here. So we're going to be doing a MVS-CMD execute on this program called ikjef01. Now, this is a way of running TSO commands in batch. So it's the same as doing TSO CMD and then a TSO command. So TSO CMD is another CLI tool. There's no help like that. Great. Okay. TSO CMD is another way of doing a TSO command directly in zOS Unix. This isn't part of zOAU. It's part of zOS. But underneath the covers, what TSO CMD runs is this program here, ikjef01. So we're going to execute this using zOAU's MVS-CMD execute authorized Python-based API. This is coming from zOAU util py library, which is part of the zOAU install. So as long as you have that all set up, there's instructions on documentation for that. You should be able to run any Python program using these libraries directly on zOS Unix. So in here, what are we actually doing? We created some temporary files that we're then pitting some content into based on a TSO command that comes in. So we're writing standard in and standard out directly to temporary files and then reading I think we're just reading the standard out back and then return that as a string output. So this is a way of just writing some nice Python to execute any TSO command you want. So at the bottom, I've got a print statement, and I'm going to run this method using the string, this user, my username. So exactly the same as I was previously doing in that Ansible playbook, where I had that 3 lines to just do a TSO CMD. This is a way of looking at that Python underneath. That's roughly what's going on here when we do that Ansible command. So run Python TSO. I get exactly the same output back. So let's go back to it. Same output as I previously got. So within Ansible, it's about 3 lines. It's a command, a module, having all this installed. I can run this off any host as well. So I can run this from my local Mac. I don't have Ansible handles all the SSH connection for me. And it's equivalent to doing all of that roughly, with a lot of Ansible SSH wrappering as well going on and making sure that stuff happens right and so you get the right return statements back. But yeah, just to give you a bit more flavor of what's actually happening underneath. Oh, there we go. So yeah, at this point, I think I'm out of demos. Go back to the slides. I don't know if you've got that app pipeline demo going, Andrew.
I am willing to give it another go unless we have some questions.
Yep. Don't see anything else in the chat, but I'll hand back to you then. Let you have another go.
Nice. So, oh, not ruin the surprise. So for a bit of debugging, I was looking at the job output, and not a COBOL developer myself. It didn't mean too much, but running it previously, it worked. So I've added a step at the top here to delete the data sets before anything else runs. Using a zOS dataset module, and you can say we want to set the state to absent for some data sets, and you can use this batch feature to run that command against multiple data sets. So I'm passing in both at once. But in theory, if I run that playbook, pass my inventory and my variables, hopefully, well, it ran a second ago. So worst case, I'll just scroll up, but hope for the best. So we've deleted the existing data sets. It's only two. It's both PDSs, but it's a source data set with this COBOL and then the compiled load library. So we've deleted them, created the source, created the load library, copy that COBOL source over. That's it. Now we're compiling it. That's what went wrong before. So Drew and I did a presentation yesterday, and the first demo also broke. So it seems to be a bit of a theme from the Andrew double act.
To be fair, that was definitely my fault for changing the variables a minute before the presentation and changing them incorrectly.
Yeah, I don't know what this used to run, one after the other. I don't know if I've accidentally changed something. So we get a load of stuff back from the compiled job. We don't have to print this out. This is just we'll extract the compile output just to see what's going on, but it's green. We get the actual compile didn't fail, so this is just reading the job output, and then we run it. I don't know if we ever looked at the run job. I don't think we got that far, but the job is called cob run. We're executing that program and passing in our load library. So if we go back to the output, we get a message, hello GSE UK, which is what we asked it to do. And just for verification, I like to look. This is Zoe Explorer for those that aren't familiar on the left-hand side. And I can look at the job output, sysout, and that's where we get that output from. So yeah, the demo does work. Sometimes it doesn't, but we got there. So any questions about that at all, or anything else for that matter? I can't see the chat at the moment. Oh, there it is.
Nothing in the chat so far.
It's not.
I think we can probably close out then, Andrew.
Yeah, fantastic. Okay, thank you, everybody. Lewis, I don't know if you close out.
That last slide. If you
Yeah, thank you. Have you guys side of you?
Yeah, hang on.
Oh, no worries. I'll shut up.
Sorry. Yeah.
Oh,
yeah, we just had the feedback slide. I think the only point I want to probably close with is we have shown you a variety of different ways of how Ansible is kind of working, how that automation works underneath. The point of Ansible in all this picture is that you can run this stuff as a service from anywhere. You don't have to be logged into USS directly. You don't have to write Python there. But 90% of the cases, you can just do a low-code interface to automate pretty much anything. It's super powerful. If you need that extra flexibility that Ansible doesn't quite provide you, you can step down to the Python, you can step down to the COAU, but it's not always needed. So yeah, thank you for listening to us ramble for the last 45 minutes.
That was really good. Thank you, guys. I was about to say one thing I actually took from that is that though the demos don't go right, I think in some ways it actually helps the presentation because you are working through and debugging kind of what's gone wrong, and that is almost a really valuable point, right? So yeah, no, really good, guys. Thank you so much for that. I certainly learned a lot. Like I put in chat, please can you give feedback? We're trying to drive that. I think across the conference so far, our feedback numbers are quite low. So if you can leave some feedback, they are all anonymous. The presenters get them, so please be honest, and they can then have a look at that and take from it what they will. But thank you very much. We will close off. Cheers, guys.
Thanks, everybody.
Thank you.
Have a good rest of your day.